Hey everyone, Mr. Kaczynski here. Today we're working through section AA of IXL's Algebra 1 skills, factoring quadratics when the lead coefficient is 1. Definitely easier when the lead coefficient is 1. So here I've got two examples. They're very similar to each other, and I'll illustrate how in just a second. So we're given a trinomial. That's kind of like the area of a rectangle. So I'm going to draw this rectangle diagram. We're given that its area is g squared plus 12g plus 11. So I know that this is g squared, has an area of g squared, and this has an area of 11. And I also know that these two boxes or areas add up to 12g. All right. So if that's the case, this length must be g, and this length must be g, because g times g is g squared. Also, there's only two factors of 11. It's a prime number, so this must be 11, and this must be 1, because 11 times 1 is 11. Now that we have those dimensions, we can fill in these missing pieces. G times 11 is 11g, and g times 1 is 1g, or just g. And just like I said, those two pieces add up to 12g. So here's our factorization. It's our length, g plus 11, or g plus 1 times our width, g plus 11. So it really doesn't matter which order I list those in, but length times width is our factorization, as opposed to this trinomial, which is our area. So let's do another one. Down here we've got x squared minus 12x plus 11. It's basically the exact same thing, except for the variable changed from a g to an x. And the middle term is now negative 12 instead of positive 12. So let's look at how that would change things. So we know this is x squared, which means its dimensions are x by x. And we know this is 11, and we would think then that would mean that our dimensions are 11 and 1, because 11 times 1 is 11. However, if we use that, we end up with x times 11 is 11x, and x times 1 is 1x, but those don't add up to negative 12x. So there's one thing we have to change, and that is that these are going to be negative. Negative 11 times negative 1 is still positive 11, but then it changes these areas to negative 11x and negative x, which would then add up to negative 12x. So our factorization ends up being x minus 1 times x minus 11. So positive and negative factors are things we have to think of. So before I move on to the other examples, the basic gist of this is that when the lead coefficient is 1, we are looking for factors of this term that add up to the middle term. All right, here we go. So we're looking, in this case, we're looking for factors of 24 that add up to 14. Blank times blank equals 24, and blank plus blank equals 14. Factors of 24 that add up to 14. So if we use 1 and 24, the product is 24, but their sum is not 14. So that's not going to work. We could use 3 and 8. Those multiply together to be 24, but they only add up to 11, and we want them to add up to 24. And I skipped the one that actually works, and that's 2 and 12. 2 times 12 is 24. 2 plus 12 is 14. And that's why our factorization here is d plus 2 times d plus 12. I'm going to show this with a rectangle diagram too. Break it up into 4 parts here. So if it's got a width of d plus 2 and a height of d plus 12, all right, its area would be d squared, d times d, 2d, 12d, and 14. I'm sorry, not 14, but 24. So the thing to keep in mind here too is that the 12D and the 2D add up to 14D. Then the d squared and the 24, we have those already. D squared and 24. Let's do another. T squared minus 36t minus 37. So again, we're looking for factors of negative 37 that add up to negative 36. 37 is a prime number. It's only got two factors, 1 and 37. But one of those has got to be negative because their product is negative. So let's make that 1 negative. So negative 1 times 37 is negative 37, but negative 1 plus 37 is not negative 36. That would be positive 36. So I need to switch where I've got the negative sign. Let's make it a negative 37 instead of a negative 1. And then 1 plus negative 37 does give us negative 36. So our factorization here would be t plus 1 times t minus 37. So the original trinomial, remember, is like our area, and the factored form is like our length times width. This times this, those are both factors of that trinomial. All right, one last one. We're looking for factors of negative 15 whose sum is 2. All right, well, 1 and 15, those add up or multiply to 15, but their difference, that's the way I would look at it, isn't 2. What about 3 times 5 is 15? So the question is, which one is negative? One of them is negative. Well, they add up to a positive 2, so the bigger absolute value should be the positive one. So we'll use negative 3 and 5. That'll work. So h minus 3 times h plus 5. I think we'll do one more rectangle diagram to show that this works. All right, so if its area, its dimensions were h minus 3 and h plus 5, then its area would be h squared. H times h is h squared. Negative 3h would be h times negative 3, and 5h would be h times 5. Those add up to 2h. And also, negative 3 times negative 5 is negative 15. So that works. And then just in summary, real quick, anytime we're trying to factor a quadratic that looks like this, when its lead coefficient is 1, we just need to look for factors of c, blank times blank equals c, whose sum is b. So it'll end up being in this form, x plus p times x plus q, where p and q multiply to equal c, and p and q add up to the b value right there. All right, so that's how you factor quadratics with a lead coefficient of 1. Good luck in IXL's Algebra 1, Section AA.